All right. Hello, everyone. Welcome to day 3, Advent of Code 2021. I'm Jared. I am a Rubyist. I build e-commerce websites. I run a company where we do Ruby on Rails based e-commerce using a platform called Solidus. Today we're doing Advent of Code puzzles. The third one is set to come out in 2 more minutes. We've already completed day 1 and 2, so if you want to check those out, I haven't put a link to my YouTube anywhere, but I have one. I'll have to fix that at some point. But I'm posting all of the VODs from these over there. I'll put that in the description of my profile or something like that in my at some point. The last 2 videos are literally the only thing on that YouTube channel, though I do have an older channel that has all of last year's on it as well, which I might just upload to the new channel. Oh, thank you, Mamesy. I don't know. What else do we want to talk about? So far, having fun this year. First 2 days were relatively easy. No stumbling blocks there. Ruby's standard library has really excellent array methods compared to a lot of languages, at least older languages. So each cons came in pretty clutch on day 1. Really made that puzzle quite easy if you knew that method existed. A lot harder if you got to do it from scratch, but we don't. We're Rubyists up in here. All right, 30 seconds. I apologize. The video I recorded earlier today had the whole stream had no music. Kind of lame, but got it going. We got it fixed. All right. Do it. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report, your puzzle input, consists of a list of binary numbers which, when decoded properly, can tell you many useful things about the conditions of the submarine. The first parameter to check is power consumption. You need the binary numbers in the diagnostic report to generate 2 new binary numbers, called the gamma rate and epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. For example, given the following diagnostic report, considering only the first bit of each number, there are 5 0 bits and 7 1 bits. Since the most common bit is 1, so sorry, there are 5. First bit of each number. There are 5 0 bits. Okay, yeah. Cool. Oh, sorry, my bad. Switch the puzzle. There we go. The most common second bit of the numbers is in the diagnostic report is 0, so the second bit of the gamma rate is 0. The most common value of the third, fourth, and fifth bits are 1, 1, and 0 respectively, and so the final 3 bits of the gamma rate are 1, 1, 0. Okay, so I did not follow that. I am tired. Considering only the first bit of each number, so this is the first bit, I think. Yeah. Most common bit is 1. Most common bit of the numbers in the second bit is 0. Okay, yeah. Most common value in the third, fourth, it's 1, 1, 0. So the final. Oh, okay, I get it. So the gamma rate is the binary number 1, 0, 1, 1, 0, or 22 in decimal. The epsilon rate is calculated in a similar way. Rather than use the most common bit, the least common bit from each position is used, so the epsilon rate is 0.01001 or 9 in decimal. Multiplying the gamma rate 22 by the epsilon rate. No, Mamesy was talking to me because I wasn't. You're still looking at just my face. Produces the power consumption 198. Use. Okay. And it's just always okay. Use the binary numbers in your diagnostic report to calculate the gamma rate and epsilon rate, then multiply them together. What is the power consumption of the submarine? All right, let's get our puzzle. Right, and whoop. Cool. All right, so we have a sample, always helpful. Right, and we're expecting this to produce 198. Cool. All right, so take some input. What are we gonna do with our input? What's the easiest way to do this? I'm just gonna run my. Cool. There we go. All right. What do we do here? What's the easiest way to do this? We take each input, split it into lines, and then map those to their characters. Seems vaguely like something we might do. Alright, and then input dot first each do each with index do. I guess we don't even care about the actual thing though. We only care about the index. So that'll loop over each digit and give me the length there. We could also do, that was actually a silly way to do that. But it's fine, it'll work. We can refactor it later. I don't know, we can, I'm gonna do this in a silly way. So, just gonna build a string. Input each, or input count there's definitely a better way to do this, but. One zeros if one's bigger than zeros. Num plus equals else num plus equals 0. Okay. And that should hypothetically build us a binary number. Let's just do this, and then we can test it. And so num is going to be 10110. That is the expected result. Is there like a, do we have a, no, I'm gonna do this some terrible way, but that's fine. Okay, so then our, what do we call that one? That's our gamma. So gamma equals num 2i in base 2 and epsilon there's definitely a better way to do this, but this is what we're doing. We got multiply these together. Gamma times epsilon. What do you think? Think that works? It works. Okay, then let's get this. Just get this default input. File.read./data/day3.txt, and let's just solve day 3 part 1. Oh no, likey. What did I just do? Oh, missed a closing paren. There's my solution. Let's see, is it right? Yes, all right. Part 2. Next, you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then, keep only numbers selected by the bit criteria for the type of rating value for which you are searching. Discard numbers which do not match the bit criteria. If you have only one number left, stop. This is the rating value for the one you were searching for. Otherwise, repeat the process considering the next bit to the right. Okay. I think I understood that. The bit criteria depends on which type of rating value you want to find. To find oxygen generator rating, determine the most common value, 0 or 1, in the current bit position, and keep only numbers with that bit in that position. If 0 and 1 are equally common, keep values with a 1 in the position being considered. To find CO2 scrubber rating, determine the least common value in the current bit position, and only keep numbers with that. Okay, yes. For example, using the same values as above, we do the thing, and we get 230. Okay, that's what I want. I think I understood that, but I want to, first we're going to just get this set up. And this time we're going to be expecting 230, but we're not gonna worry about that. For now, I want to refactor this because we can do better. We want to go 0 to input length, I think. Whoops. RSpec. Okay, that broke it. And it broke our normal one, which is interesting. This is supposed to be -1. That couldn't be it. No. Is it that? No. How are these different? Oh, it's input.length. It's input.first.length. Now it's totally wrong. Cool, just trying random things until, okay, there we go. That's what I was trying to do. I was gonna, do I need those friends? Let's find out. Okay, so that's that. And then I want to do that for now. Actually, I want to do so I need to implement a most common digit method that takes the index. Essentially, I don't really care. The input's not so big that this is a problem. And I mean, we can't def least common digit at an index. Actually, we don't. Oh no, we don't. Well, first let's test that this what I did just worked. Yes, it did. The failing test is the one for part 2 that we haven't started. That's fine. And then least common. So let's say. Now we have gamma and an epsilon, and we can say gamma plus equals that, and epsilon. Cool. We can delete all this jank and just convert them both to binary, and this should just be seems like it should work. Seems to work. All right, let's use those. So for this one, we want a different solution, but we're gonna depend on the similar logic. So we need to multiply oxygen by CO2 scrubber. Oxygen times CO2. And we can just go implement those. actually do one slight refactoring. Call this bit positions. Ooh. Cool. Still just one error. That's fine. All right, we're back into it. Part 2. So bit positions and so we got the input. Input equals input button. So we'll just dupe the inputs. This is fine. And then we'll just go until I don't know, position equals 0. I guess we don't even need the bit positions here. Until input.length. It's 1. And here we're going to return input.first.join 2i2, I guess. Oh. Input select sorry, so a digit we're looking for is going to be most common digit for the given position, and then we're going to we'll just mutate it. Select bang bit, sure, and no, it's not a bit. It's a what are these things again? Values in the they're just values. I don't know. Value position equal digit. Position music one. And I don't know, that seems like it would be the right thing. Sure. And then CO2 is the same thing, but for least common digit. Is this coherent? No. 220 is very close to 230 though. What do you think I did wrong? Copy the, no, it's 230. Which one of them's wrong, do you think? Oxygen is supposed to be 23. Did I not follow instructions? Okay. Determine the most common value, current bit position, and keep only numbers with that bit in that position. Keep values in a 1. Oh. Maybe that's something we need to deal with. We are off by 1. Okay, let's go check that. I guess we can validate that theory. We can just do like raise if 1s equals 0s. No. Oh, whoops. Raise if. Wow. Okay. That is not it. What the heck? Would I do something backwards? So. Common value 0, and keep only numbers with that bit in that position. 0 and 1 are equally common, keep values with 1. Okay, yeah, but we've established we haven't seen that happen. Define CO2 square and determine the least common value. Yeah. One zero one zero. All right. Well, let's do it. Let's step through it. All right. So in this moment, input is the full input, as expected. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 0. Okay. Start with all 12 numbers, yeah. And we're ones. So we're going to keep those ones and those ones. One, 0. Yes, I can see our correct answer in there still. We still have our correct answer. We still have our correct answer. So we're down to those 3. Yes, correctly. The fourth position, 2 of the 3 numbers have a 1, so keep those 2. That's correct. Oh, and this is where... Oh, it's the remaining numbers. Okay. Gotcha. Okay, so that's the problem. Okay, so we can fix that. We were considering all the numbers instead of just the remaining ones, and we can do that by we'll just do a default argument, so we don't have to change everything. And just to make sure I got that right. 0, I'm gonna keep ones. Fortunately means I have to duplicate this logic, I think, but or I probably don't have to, but I'm going to. Wow. I forgot how, let's just. That's. Like I said, I will be going to bed very shortly after I finish this. Alright, let's see where we're at. Okay, we've broken everything. Add input. Oh, and that's because we didn't fix this one. Alright, there we go. It works. So let's solve day part 2. All right, there we go. So wasn't beautiful, but we could like refactor this in a bunch of different ways. I'm not going to do that now. I'm fine with this. Might do that tomorrow as a little warm up. Git commit part 3. Sorry, day 3, part 2. But thanks for coming out. I will be back here tomorrow night to do day 4. So hopefully I will be well rested and better prepared to read through the puzzle. All right, thanks everyone.